Thank you very much. Just sorry for the delay. We had some technical problems here. Sorry, do you hear me? Is everything working and see me?
Yep, it's good.
Yeah. Okay, then, yeah, let's go. So, first of all, thank you very much for inviting me to this seminar. So, I had the pleasure of being a part of the ROS-Industrial Consortium in Europe for almost 5 years now. I've also been participating in US and also had the pleasure twice to be in Singapore. Fortunately, this year is different, as you know, because of the COVID-19, but still very happy that we could have this virtual event. So the presentation today is called ROSWELD, ROS-based industrial or framework for planning, monitoring and control of multipass robot welding. Next. Yeah, very short about our company. We are located in Trondheim, in Norway, the third biggest city. We call it the capital of technology in Norway, where we have a famous university. It's also and a lot of high-tech companies like PPM Robotics, which basically dealing with the high-tech robotics. We're also quite far north, as you can see, so we also have the pleasure with the 24 hours day in the summer, and also during the autumn, like now, we also have the Aurora Borealis. So it's very dark outside, but still, it's very nice to be here, and very good to have the darkness to dive into the high-tech. Next. So our company, we have basically been working with the high-tech robotics installation within grinding, welding, and handling. And we have delivered mainly to Norwegian industry. We also have activities continuously on R&D to be able to always have the latest technology available, so we can provide that to the industry. And as you see to the right there, thanks to the ROS, it's possible to do this, to have a business from this, even though it's quite risky to work in the high-tech field. Next. So just as introduction, try to explain our main advantage of ROS. If you see the picture here, you have the vertical axis. It's the complexity of the projects. Let's say on top you have the high tech, and on bottom you have the low tech off the shelf. And on the horizontal axis, you mainly have the let's say the scope or required resources. And as you see here, you have the suppliers to the left, end customers to the right, and the integrator in the middle is trying then to merge the technology from the supplier to the expectation from the end customers. And as you see, when you start a project, if you are on the bottom of the vertical axis here, where basically off the shelf, the end customers and suppliers, end customers have a kind of good expression of the scope of the project, because it's mainly off the shelf, so you can show him basically what kind of equipment you're going to put together. But if you go higher on the vertical axis, you will have a bigger deviation between actually the customer expectations and actually what is the real scope of the project. So in general, the end customers, it's difficult for him to understand that you have to maybe do things 10 times in the lab before it's working properly, when he, as the end, is only going to get delivered, for example, a special gripper or just a special software. So this makes the business quite difficult, and that means that you have a real cost, which is normally much higher than the actual cost in high-tech project, and this makes it really hard normally to do the business. Next. So you mainly, with the traditional technology, have two choices. Either you can't agree with the customer, and then because he doesn't understand why the cost is so high when he requires new technology, or you have to accept to take a big risk and basically often lose money yourself. Next. However, thanks to the ROS and also PPM's special module in ROS called FlexQE, the drag and drop interface, where you can, during seconds, just make user interfaces for the customer and then easily explain him how to operate, how to use the system even before you have developed it. If you see from the right, you are able to communicate much better with the end customer in the beginning. And if you see to the left, the ROS then makes a bridge between what the suppliers deliver and actually the technology you are going to deliver to the end customer, thanks to the open source technology. And an example of this is we had one project in Korea where our customer was going to buy a 3D vision system for 30k euros. We told him we could do it in ROS for him. Then we had hardware costs around 5k euros, and we could run the entire project for him for 30k euros. But then he had the advantage that he had the software, so he could easily multiply it afterwards. We spent around 2.5 weeks. So our cost was around 50k euros plus the hardware, also 5k euros, sorry, plus the hardware, so around 10k euros altogether. We sold it to the customer for 30k euros. And then, thanks to the ROS, he was much more happy. He had a higher technology. He could easily multiply it from our side. We had then 20k euros on our bottom line after this project. So this is kind of a nutshell why we are active on the ROS side. Next. So we also had the pleasure to run a FTP project, that's a focused technology project, under this the big European project ROS-I. We had one project called a black box, where it's basically a software hardware box that you can put into your robot cells or manufacturing cells in the industry, and then log all the data. And then if something's happening, you have easily disaster recovery, because you can basically go back and have both video synchronized with all your parameters, so you can easily analyze what's happening. The biggest project was what we call a ROSWELD, where we basically tried to move our experience from a high-tech robotics welding project, as you see to the right here, of huge, this was actually a hydropower turbine, and move this technology into ROS. And the core topic here was multipass robot welding to make a kind of modular ROS software library where you easily could set up welding applications for the industry. And of course, part of this was both to make a modular system, and also, of course, also provide a very user-friendly user interface, and so then make it easily to apply this for future industrial applications. And this was also a purpose of the ROS-I project, then, to make real industrial demonstrations to really to show that ROS has something to do in the industry. Next. There were 3 phases in this project, where we started with the connectivity, basically the drivers. Then we had the planning module, and then we started the demonstrations, and then finally provided everything to the ROS repository. Next. 3 partners, PPM Robotics, we were the coordinator, and mainly the software providers. In addition, we are working with the Mechatronics Innovation Lab That's one of the, what we call the catapult centers for robotics and manufacturing technology in Norway, where that the government has supported in collaboration with the industry. It's very similar to ARTC, actually, in Singapore. In addition, we also had the industrial partner, Rainpower Norway, which is one of the biggest and most advanced worldwide manufacturer of hydropower turbines. So we had a budget 300k euros, and we had a ROS-I support 100k euros. Next. So the purpose again is to make software models on the, I say, industrial level, because through such a project it's impossible in practice to have a bug-free software that you can just copy to the next project. However, the purpose was really clear to demonstrate this as an industrial application, and of course then with documentation, training material. And also with the industrial verification with the pilot case in Rainpower. Unfortunately, because of the COVID-19, the final demonstration was a bit limited. We were able to run a test. However, we were not allowed to enter the company during the last 6 months. So we have the main test so far in our lab. And of course, the important ROS-Industrial reference. As far as I know from the ROS-I project, I think this is one of the main projects being the reference from there. Next. And the functional requirement, planning module. So you could easily set up your welding application. Then a simulation module where you could verify the robot program and the welding task. And then control of the welding process and the robot. The possible to observe, that means monitor the process or check the process after welding and store the data. And then have a data storage of the data afterwards. You actually have a verification also of the welding process itself, which is very crucial in heavy welding, due to the fact that if you have, let's say, 50 layers and you have done something is going wrong with the second layer, you actually have to use cold burning and remove all the other layers and go back and start from the beginning again. So it's a very important part. It is much more important in heavy welding compared to only single pass welding. Of course, also it had to be modular, so you could easily adapt the software modules to different types of robot sensors, etc. Next. Utilization of ROS. We have the FlexGUI 4.0 that we have uploaded to the ROS repository. That's, as I mentioned, the drag and drop user interface that you can run on any type of platform, and during a few minutes just customize nice user interfaces. It's of course very important when we talk about industrial applications, that it's easy to use and also easy to customize. We use the MoveIt for simulation, ROSBag for data storage. I think we have upgraded to ROSBag 2 now. And also having interfaces for multi-languages like C++ and Python. I think there are also other languages you can use here when you make your own applications, and also a set of pre-made ready-to-use drivers. Next. The hardware components are basically very flexible. So, however, in our case, we are using robots from both actually from OTC and ROS-I. And the reason for this is that PPM, we are partner with ROS-I Fujikoshi in Toyama in Japan. They are the main providers to Honda and Toyota, Nissan, etc. So we have, they are actually using the FlexGUI as a part of their robot controllers. PPM is supplier, developer of that. ROS-I, Diane in Kobe, they are using same controller as an ROS-I, so that means that we can just easily swap these controllers and robot and using the same software and for it. We were using ROS-I welding source. We're using a standard laser scanner, not for the scanning, for the online scanning, but the offline scanning after the welding. And then we had a camera to monitor both the process and have an overall monitoring of the welding robot cell, and and also a PC running the software. Next. Yeah, as you see here, the system structure, you have the ROS library in the bottom, and then we have the ROS switch communicating with the flex screen. We have laser scanner drivers, welding power source driver, ROS-I, ROS-I drivers, and of course these drivers are can mainly be adapted, and actually we have a quite big library here. So if you use a Motoman or Koka robot or whatever, you can use it on any welding power source. Next. I think we can go to the next. Time is running a little. Yeah. We set it up in our lab with an ROS-I MR20 and ROS-I welding equipment with a MEL laser scanner, Cisco AP camera, and as a server and a Galaxy tab. So what is important here is that we actually could then run a very heavy welding application just using a tablet, and have a very user-friendly environment for the guys on the shop floor. Unfortunately, we were only able to run it in our lab so far, but we will continue. Hopefully, when the COVID has stabilized to rain power. Next. So the steps here, I have attached a video also that you can take a look at after the presentation. It's a part of the PowerPoint. But first of all, as you see, we have a calibration of the workpiece. You see the flex GUI user interface here. You basically move the robot to some defined positions on the workpiece and just press a button, and then you align the workpiece with the geometry inside the robot controller. Next, the path planning. Here you can upload CAD, or you can just draw it by the cursor to show where you're going to weld, and you can build up also multipass welds. We also have a hidden module where we can actually predict all the passes we need to fill up a huge groove of welds. But this is something we haven't shared on open source due to the fact that this is part of Rainpower's property, and we spend actually 200k euros to develop this during a neural network. But I mention it that it's actually possible now. I think it's the first time in the world that someone has we have been able to do a full model-based welding of multipass, heavy multipass welding systems. Next, we have a simulation with the full dry run, so we can check the kinematics of the robot. And here also we can set the welding parameters. That's a vertical axis, and also the horizontal axis is more like a video where you just easily back and forth to check individual positions. Next. Then we can have a dry run of the welding program, just running it without the welding power source running. And also here, if you see the horizontal axis, you can just move it back and forth, and the robot will follow continuously. And this is also quite unique that you have this direct connection between the tablet and the and actually the robot position, so you can easily go back and forth and do editing. Next. Then running the welding program, and here also you can follow all the welding parameters on the vertical axis continuously, see the value, and also run see how all the parameters are changing according to where you are in the robot program. Next. And finally, if you would like, you can just run a verification path. As you see here, we are using laser scanner, and then we are tracking the weld. And of course, this is also synchronized with all the welding parameters. So you have a kind of data set afterwards where you can go just back, see the video, see the geometry of the weld, and also see all the welding parameters. So it's a, let's say it's a kind of complete here, including the quality inspection. Next. Yeah, as you see here is the video. We don't have time to run it for today. Actually, I'm so I'm just telling you the last around 4 minutes, but then you can see the entire procedure. Next. Yeah, so that's a short sum up of the ROSWELD project. You can find more data on it under the ROS-I website, which presenting all the FTPs running under the European ROS-I project. And of course, also there you can download the video. You also have my contact details here in case you would like more info about the modules or you would like to apply it in one of your applications. So then, thank you very much.